This video will be about interpreting graphs. So when we have a graph, no matter what it looks like, it always has some of the same features. So let's say we have a line. So we can look at this line and find some of its important features. Where it crosses the y-axis is called the Y-intercept. So this one would have a y-intercept at 3, or you could name it by the actual coordinate 0, 3. Where it crosses the x-axis is the x-intercept. So it has an x-intercept of -3, or its coordinate would be -3, 0. This x-intercept can also be called a zero of the function. The x-intercept is a little more special than the y-intercept, so it gets a second name of being a zero. Now, one thing a line doesn't have is a max or a minimum. So I'm going to draw a second graph. And let's talk about its special coordinates. So this still does have a y-intercept at -1. It still has x-intercepts or zeros at 1, 4, and 7.5. But now our graph also has a maximum and a minimum value. So our maximum value is the tallest point. My drawing was not perfect, so I'm going to say that it did cross exactly at 3, 1, even though my graph was a little bit off. So the maximum is actually 1. It's the y value. It's located at 3. So the max is that value of 1 because you're one space up. The minimum, again, it didn't cross exactly, but I'm going to say it crossed at 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5. So 6, -5. So the minimum would be -5, and it's located at 6. So the minimum is the -5 because it went down 5 spaces. So no matter what the graph looks like, if it has one of these special features, we can name it. We've seen kind of a curvy graph, a line. I could also do something more like a V-shape. So the V-shape doesn't cross the x-axis anywhere, so it doesn't have any x-intercepts or zeros, but it does have a minimum value, and it does cross and have a y-intercept. So no matter what the graph looks like, we can still find these values. There are certain names for the types of graphs you can see. So when you have a straight line, this is called a linear function. When you have a U shape, and this could face up or it could face down, it doesn't matter. This is called a quadratic or a parabola. We also have an exponential function. Exponential starts high and goes low. And then absolute value is a V shape. Now there are other types of graphs besides this. These should be the only ones you're asked about, And specifically, linear is the one that you're most likely to be asked about. And that's the one that's easiest to remember because it includes the word line. A linear function is a line. They will ask you to find which equation represents a graph, but it's easier not to try and memorize this means absolute value, this means quadratic, etc., but to actually take a point on the graph and use that to check in the equation options they've given you. So let's use this minimum point, which is located at -3, -1. And let's plug that into our first option, answer choice A. They use f of x, but really that's just y. So I'm going to replace it back with the letter y, so it's easier to work with. So we're going to replace the letter y with the -1, that is the y coordinate. We're going to replace the letter x with the -3, that is the x coordinate. When working with absolute value, we need to do what's inside the absolute value bars first. -3 minus 3 is -6. Then we need to actually take the absolute value. The absolute value of -6 is +6. And then 6 minus 1 is 5. Now these don't equal each other. That means this first answer choice is wrong. It did not work. So let's try answer choice B. Replacing y with -1 and x with -3 again. Do inside the absolute value bars first. -3 minus 1 is -4. We take the absolute value of -4. Absolute value of -4 is +4. When you do that, it leaves multiplication, so this will become 2 times +4, which is 8. And then 8 plus 3 is 11. Now again, this doesn't work. Our answers did not match at the end. So I'm going to erase all this work so we can try answer choice C. So answer choice C is y equals 2, absolute value of x plus 3, minus 1. We plug in -1 for y and -3 for x. We do absolute values inside the absolute value bars first. -3 plus 3 is 0. And then take the absolute value. Absolute value of 0 is still 0. Then we multiply. 2 times 0 is 0. And 0 minus 1 is -1. So that one did work. Now it is possible for more than one answer to work. If we try D, y equals absolute value of x plus 3 minus 1. If we try D, we actually end up with, sorry, that was a 0. It kind of went wonky there for a second. 0 minus 1 is -1. D also works for that particular point. When that happens, we do need to check a second point just to be safe. So this coordinate is the coordinate -2, 1. So let's try this coordinate. Plug in 1 for y. Do inside the absolute value bars first. -2 plus 3 is 1. Absolute value of 1 is 1. 2 times 1 is 2. And 2 minus 1 is 1. So C worked for this second point. So most likely when we try the second point on D, it is not going to work. Plug in 1 and -2. -2 plus 3 is 1. Absolute value of 1 is 1. And 1 minus 1 is 0. So for sure D is not the answer, and the answer is C. Now this method is a little bit time consuming, but it's easier than having to memorize a whole bunch of different functions and how they work. It will work no matter what the function is. You can always pick a point and plug it in to see if it gives you the correct answer. One last type of question is when they give you a distance-time situation to interpret. So Carlos rides the bus to school, then spends 6 hours there. He decided to walk home, and halfway home stops at the library for 1 hour. He then continues on until he reaches home. Draw a graph that could represent his distance from home. So we have the time, and we have his distance from home. The first part of the situation says he goes from home to school, and he's riding the bus. So he's going to go pretty quickly. So if he's home, then his distance from home is actually on the axis. He's not far from home at all. If he rides the bus to school, he's going to be going pretty fast, so it'd be a straight line up pretty quickly. Then he spends 6 hours at school. So when he's at school, his distance from home doesn't change. That's going to be straight line for a while. He walks home, so walking home is not going to be as quick as riding a bus. So the line's not going to be as steep. Then he stays at the library for an hour. So that's a straight line again, but not nearly as long as the original one. The original straight line was for 6 hours, so not nearly as long. And then he finishes walking home, which again is not as steep as riding the bus or being in a car. So that is our distance and time graph. The steeper the line, the faster you're going. If it's a straight line, that means you're in one position. And if it's not as steep, and this is going down, so he's going towards home, whereas the original line was going up, so he's going away from home. So that concludes our discussion on interpreting graphs.